Good morning, ladies and gentlemen. Welcome to our panel discussion on future of electric vehicles. As the global community increasingly prioritizes sustainability and seeks innovative solutions to combat climate change, the role of EVs in shaping the future of transportation has never been more crucial. Today, we are privileged to be joined by a distinguished panel of experts, each offering unique perspective and insight. Now I will invite Professor Hussain Shareef from UAE University to come on stage and join us for the panel. Professor Hussain Shareef groundbreaking research delves into optimization of fast charging stations, deployment and the hybridization of energy sources in EVs. His projects not only addresses the technological challenges but also consider the broader implications for sustainable urban planning and energy grid management. Welcome, Professor Hussain Shareef on the stage. Now I would like to invite Dr. Manar Almazrouie from United Arab Emirates University to come and join us on the stage. So Dr. Manar research aims to revolutionize energy storage solutions through the development of advanced electrode materials for sodium-ion batteries. Her innovative approach not only enhances the performance of EV energy systems, but also contributes to the broader transition to renewable energy sources, positioning the UAE as a leader in clean energy technology. And lastly, we have Dr. Mustafa Shaban. I will talk about his research. So Dr. Mustafa brings expertise in power system operation and smart grid technologies with a focus on reliability, security, and the integration of renewable resources and EVs into the grid. Dr. Shaban research offers crucial insights into the intersection of EVs and energy system. Together, our panelists will navigate the complexities of EVs ecosystem and from technological innovation and infrastructure development to market dynamics and consumer behavior. As we explore the future of transportation, we invite you to engage with our esteemed panelists and contribute to what promises to be a stimulating and insightful discussion. Without further delay, let's delve into the conversation. So I will ask my first question from Dr. Hussain Shareef. Doctor, your research focuses on optimizing the deployment of fast charging stations for EVs. How do you envision the future of charging infrastructure, particularly like in urban areas of UAE and worldwide? And what challenges must be addressed to ensure seamless integration with existing transportation network?
Thank you very much for your question. I think the main issue is the range anxiety for electric vehicle users. So that means that anxiety means that the user don't want to stop the car in the middle of the road. They don't know when car is available. That's why it's important to plan charging infrastructure around this. So for that one, we need to look into many things. First of all, vehicle fleet. As you know, in UAE, by 2030, 60% of the vehicles are going to be replaced by electric. That means a large number of EVs are going to be on the roads, and the sufficient EV charging stations are required. So long-term planning is required for that. For that, we have to look into the number of EVs in the urban areas, and also we have to look into the traffic. We also have to look into the energy grid, the amount of energy that is required to power up those cars. Those are the things that we have to consider when using charging. Other than that, there are other charging infrastructure as well. There are three levels of charging: level 1, level 2, When you talk about fast charging station, it's level 3, high power, easy charge. The other levels are at home, you know, charge low power, and also in the urban areas like malls and so it is very important to look into all the in the parking areas. The problem is that when you throw a lot of energy from power system, in the future there will be a lot of demand from people. So there should be a way to address how to get the extra energy demand on the road. That's one thing, and also to cater for that, we need some other solutions like renewable energy solutions. Maybe for the charging station as well as parking places, we can cover the shading by photovoltaic systems to help the grid to produce the extra energy required by electricity.
Thank you very much, Dr. Hussain Shareef. I will come back to you now. I will ask Dr. Manar Almazrouie. Doctor, your research is focuses on enhancing energy solutions for EVs through advanced electrode material. How do you anticipate these advancing impacting the performance and affordability of EVs, particularly in the context of United Arab Emirates Green Mobility Goal?
Thank you so much. So, we know that the most expensive part in electric vehicles are the batteries. And most of the batteries now are lithium-ion batteries. Now, with the current demand for electric vehicles, it is expected that, of course, lithium consumption will be increasing. Thus, it is expected that there will be shortage in lithium in a couple of years. That is why we need an alternative. For example, in 2021, 74% of the total lithium has been used to produce battery material. Now, one of the most attractive type of batteries, especially in this part of the world, is the sodium-ion batteries, because sodium, thanks to sodium is cheap and is abundant. Also, in UAE is one of the areas that can scale up sodium-ion batteries easily, simply because we have desalination plants, and sodium is a byproduct of these water purification technologies. So that's one way, is to shift from lithium to sodium-ion batteries. The second way, of course, with shifting to sodium, we will not only have this abundance and sustainable material, but will also reduce the cost. So it is expected that we can reduce the cost of battery pack by 30% when we use sodium. The second part in how we can reduce the overall cost of batteries in general is to use innovative material in synthesizing those particles or those battery materials. Now, the conventional methods are depending on something called co-precipitation. Co-precipitation is the conventional method. So most of the battery material now used or available on the market are used or as synthesized by this type of synthesis methods. Again, this method is very long method, a multi-step method, a very expensive, non-environmentally friendly. That's why we need to shift to other methods. And one of the methods that I recommend or I have used myself in reducing my batteries called the ultra-fast aerosol spray versus method. It's a single-step method, can reduce the time of producing batteries from multi-days to only a couple of seconds. And I think it will be the future of battery material synthesis and innovation in general.
Thank you very much, Dr. Manar. I will come to Dr. Mustafa Shaban. Doctor, your expertise in power system operation and smart grid technologies. How do you see the integration of EVs into grid impacting power system reliability and the management of renewable resources?
Thank you. Thank you, Luqman. This is a very good question. Given that the power system was not originally designed to accommodate this extra load, and when we are talking about electric vehicles, we are talking about plug-in electric vehicles in specific. The electric vehicle can plug them to a charger or even to a regular outlet and recharge your battery. So the power system was not originally designed to accommodate this extra load, and the challenge is that the power system operators will be facing mainly on two aspects. The first aspect is supply adequacy. Do we have enough generation? And if we plan to even build new generation power plants, can we cope with a rapid increase in the electric vehicles? If you buy electric vehicles tomorrow or the day after or next week or next month, you expect that the utility will allow you to install a charger at your home. This will not be always the case. Not just on the supply level, on the country level, but even on the distribution level. The feeder supplying your home or your villa might not be able to withstand this extra load. So one of the major challenges is mainly the infrastructure of the power system to accommodate a rapid increase in EV. This is where the operators of the power systems need to go on two sides. One side is be ready to this rapid increase, and another side is to accommodate technology in managing the electric vehicle chargers. So I can allow you to install a charger as long as I have upper hand to deactivate it when, because if it is uncontrolled and it's only in the hand of the owner of the EV, it might not be visible, and technically I will not allow you to install it. And one last point is about the integration of renewable resources on the grid side. Now, the shift to electric vehicle is mainly driven by reducing emissions. If you just make the transition from conventional to the electric vehicles and keep supplying the grid by the conventional resources, the oil and the gas, etc., we are just shifting the emissions from the transportation sector to the electricity production sector. So you will not have that impact on the emissions. So with this transition to electric vehicles, there should be another transition side by side on the grid side to increase the penetration of clean energy. And there is a difference between clean and renewable, of course. For example, the waste to energy is a renewable resource, but it's not clean. On the other side, nuclear energy is clean, but it's not renewable. So I talk about clean energy, prefer to be clean and renewable. Thank you.
Thank you, Dr. Shaban. I will ask a follow-up question from Dr. Hussain Shareef. Doctor, a lot of your projects you are working on hybridizing energy resources in EVs. So you emphasize the importance of prolonging the lifespan of EV's energy system. So could you more elaborate on how adaptive energy management strategies contribute to both efficiency and sustainability in electric vehicles technology?
Thank you very much. Question. Hybridization of EV means that currently we have, for example, only battery-powered vehicles. So the batteries sometimes is considered as high energy density, but no high power density. That means in the case of when you require acceleration, fast acceleration, then batteries cannot provide enough energy to accelerate the car. Therefore, it is necessary to hybridize with other sources of energy, such as ultracapacitors, that can provide high power in a very short time. So when we have multiple energy sources, this means that we have to have an energy management system which source should provide power at a particular time. So this means that energy management should be dynamic and adaptive, and it should take care of the charging and discharging. For example, brake energy should be used to charge the battery or the alternative path. So that's why it is very important to have intelligent and adaptive energy management.
Thank you very much, Dr. Hussain Shareef. Coming back to Dr. Manan, can you elaborate on the scalability of aerosol spray pyrolysis technique for synthesizing electrode material? And how might this method contribute to large-scale production of sodium-ion batteries and accelerate the adoption of EVs on a global scale?
For this question, aerosol spray process method are very scalable, so we can produce tons of materials per day. Not only that, but we also can control the morphology, the structure, the stoichiometry, and the elemental mixing of the battery materials, cathode and anode materials. Now, the conventional or the first generation sodium-ion batteries are using hard carbon as anode material. Now, the hard carbon is low density, so compared to the graphite that's used in lithium-ion battery. So the density is 1.6 gram per centimeter cube compared to the 2.2 gram per centimeter cube of the graphite. It means that the overall gravimetrical or volumetric energy density will be less for sodium-ion batteries. That's why we need alternate. Now, we still can produce hard carbons by the aerosol processes. It's a single process, single step, can produce things in multiple seconds compared to the multi-day processes used in industry. But we need to solve the energy density problems in sodium-ion battery. Now, one way to solve that is to use alloys like copper or other different metals of alloys. And we have produced those alloys by spray versus method. But one of the challenges with the sodium is the size. So sodium 3.3 times larger than the lithium ion. It means that during the intercalation, during the charging and discharging, there might be changes in the structure, in the anode structure sizes in general. That's where the aerosol synthesis method can help in modify the morphology. So we can produce porous structure, for example, or hollow structure or core shell that can mitigate the volume change during the charging and discharging. Number two is the cathode material. Now, most of the cathode materials for lithium-ion batteries or sodium-ion batteries are layered oxide structure. These oxide structure are multi-element. So, for example, in Tesla Model 3, they use the NCA, which is the lithium, nickel, cobalt, manganese oxide. Now, to produce such a material, we need to have homogeneous mixing. Some of the researchers found that using the aerosol method where you mix the elements and metals in solvent at the beginning can enhance the mixing, of course, and can enhance the diffusion coefficient of the sodium in the cathode structure compared to the conventional method like the solid state or the copper substitution. The third thing with the aerosol method, not only synthesizing advanced material, but also we can recycle batteries. Now, one of the challenges with the batteries is the end-of-use batteries in general, what we should do with the particles or what we should do with the materials. Again, aerosol spray versus method or the ultra-fast method can help us to extract those particles, mix them with a fresh precursor or fresh material, and spray them or reuse them again. So, again, the innovative ultra-fast processor, I use them by myself and I developed them, can not only improve the performance of the innovative battery material, but it can help us to recycle the batteries as well, recycle the battery material as well.
What about the cost of when we are using the same material, so the cost?
Okay, it is much cheaper, of course, because, again, when we talk about co-precipitation, we talk about multi-steps method. So we start with the sulfate, for example. We need to have a special design of reactors, wait multiple days to precipitate the metals, using ammonium hydroxide, very controlled pH environment, get those particles, wash them, filter them, dry them, mix them with the ions like sodium or lithium, and then we need very high temperature extended annealing processes. It can take 48 hours of annealing to get the final crystal structure. But when we move to ultra-fast synthesis method, we can, again, minimize the time from multi-days to only a couple of seconds or couple of minutes. So for the anode material, it can for sure be multiple seconds. For the cathode material, we might need extra step of heating to get the final crystal structure, but that won't exceed a couple of minutes because, again, we have homogeneous mixing at the beginning. Take into account that we are using environmentally friendly method, right? We are using metals that dissolve in water, not there is no ammonium, there is no kind of toxic material, so we don't have to deal with actually waste chemicals in this process. And we don't need a lot of man or like humans involved in the process. It's only single process, one reactor. You spray those materials in high temperature reactor, collect them in a filter bag or collection bottle in the in the other side of the reactor. Now people might ask why industry are not using this method. Again, because the commercial material, which is lithium cobalt oxide, has been produced by the co-precipitation from 1990. So I think industry is hesitant to kind of have this change or spend time and money in innovative processes to produce innovative materials for batteries. But going back to your question, yes, we can dramatically reduce the cost.
Thank you very much, Dr. Manar. I will come back to Dr. Mustafa Jaban. Doctor, as electric vehicles become more prevalent, so what do you think, what are the key challenges and opportunity in terms of smart grid, grid infrastructure and energy management? Like what will be the key challenges?
Very good question, Dr. Luqman. So, one of the key challenges is related to what I was talking about previously, which is introducing technology and two-way communication with these chargers. So cybersecurity will be one of the major issues attacking the infrastructure of the EV charging, especially if you have a high penetration and a widespread of EV chargers, might cause serious problems for the power system, especially that the power system is one of the very sensitive infrastructures. We don't have storage, massive storage or a storage, cheap storage option like water networks. We have the tanks. So for the water networks, any sudden increase or decrease in the consumption of water, they can accommodate it. On the electric system, this is not the case. So attacking an infrastructure of EV chargers, either by increasing suddenly or reducing suddenly, depending, of course, on the amount of EV chargers and the number and the distribution, might cause a big problem. The second problem is the geographical concentration of the EV chargers. So we expect the EV chargers to be concentrated geographically in residential areas more. And their peak gonna be when, seen, of course, the highways. The highways, one way is we have heavy traffic in the morning, the other way we have heavy traffic in the evening. So when you go back home, everyone start plugging their EVs in their chargers. These chargers are not going to be uniformly spread over the grid. They are going to be concentrated in some residential areas. And these residential areas, from a power system perspective, they are not intensive loads. The intensive loads are in the industry and the commercial loads. So when we have this sudden increase at a certain time of the day, this is also a big challenge for system operators. But again, given that the EV penetration is high, one of the big opportunities, I would say, is a technology that it's starting, but not very common about in commercial passenger cars, which is battery swap technologies. So the battery swap, its major advantage, of course, it's costly, but its major advantage that you can charge the battery overnight, and then the battery can be replaced in your car in minutes. So the consumption itself from the power system is very flexible, and it will not happen at the point when you replace your battery. But of course, these battery replacement technologies not going to be at your home. It will be in stations on the road, similar to the fueling station, the gasoline stations. And also, it doesn't have to be the full battery of the car. The full battery of the car is very expensive. It can be 10% or 20% of the battery of the car. You drop by the battery swap station, it gets replaced in minutes, and you continue your journey. So you get a boost of 20% that will allow you to reach your destination. And it just took you 5 minutes, similar to any gasoline station. And this is much easier as power system operators to accommodate compared to accommodating these fast charging stations on the roads, again, that are going to be geographically constrained. Thank you.
Thank you. So, we are talking about the charging station, so I will ask Dr. Hussain Shareef also about the. So, Doctor, what do you think, like, what advancement in the charging infrastructure, especially for the urban environment, we are talking about? So, what do you think, what advancement we need in the charging infrastructure?
Thank you very much. Actually, regarding the chargers, there are, as you said just now, there are many technologies. One is the battery swapping. That's very fast. It takes less time to charge a battery to 100%. There are other technologies like the plug-in electric vehicle. You see the supercharger, for example, for Tesla. They can charge the car to up to 80%, and that is 30 minutes. These are the technologies, but the future, we are looking into new technologies. Just like your mobile phones, nowadays we are using a wireless charger, right? So in the future, you don't need a plug-in charger, but it's going to be replaced by a wireless charger. You just go and park, and there's something underneath your a charger or some kind of coil that wirelessly charge your EV batteries. And then other advancement should be like innovative and smart technologies integrated into the chargers. For example, nowadays the batteries are charged as a constant current and constant voltage. In the beginning, it's constant voltage, current, and then later on. But if you want to charge a car faster than that, is intended fixed for like example, but charges in like 25 minutes to up to 80%. But in the future, maybe you can give an option for the user to choose the time that you want to charge. In our research, we also look into something called a variable charge. Variable charging means that you can ask the user how long you want to stay in charge. So that means the power of charger increases if you give them, if you ask it to charge in a short time. But the disadvantage is that when you charge a battery in a short time, the life of the battery is going to be less. So you have to do a compromise. There should be some kind of algorithm that can compromise between charging, fast charging, as well as to reduce the lifetime of the, increase the lifetime of the battery. In other words, the state of health of the battery source could not degrade that much. Thank you very much.
Thank you very much, Dr. Hussain. I will come to Dr. Manar. Doctor, as we know, we are from academia, and collaboration with industry stakeholder and research institution is crucial for driving innovation in clean energy technology. So how do you envision partnership between academia and industry contributing to the development and commercialization of sustainable energy solutions, including advanced energy storage systems for EVs also? So what do you think about this partnership between industry and the academia research?
That's very interesting question, actually, I think the first thing, we need to do 3 steps here. The first step is to minimize the gap between industry and academia. And the first step, under the minimization is to actually gain the trust. We need to gain the trust of the local industry, the local investors, and the local market. We need to have this loop between the local academic institutes and between the industry, where we can get the feedback from the consumers and customers about the challenges they are facing in the local market, solve them in the local academic institutes, and then send them back to the market. So we need to optimize the batteries locally. And as you know, maybe in this part of the world, we might have challenges that are not in somewhere else. Example, the temperature. So we might kind of suffer from low performance because of higher temperatures compared to colder environments. Now, the second step as academic, we need to train researchers. We need to train the inventors, innovators, scientists, researchers to kind of lead the market, to lead the next generation of local electric vehicles market. So we need to kind of have seminars, have teaching courses, because those researchers can be, the next founders. They can be the next, owners of the startup companies, local startup companies in the UAE, especially if we're talking about converting the transportation here into electrical mobility sector. So we need to have local experts. The third thing I think, since we are talking about alternatives, here we are talking about sodium or sulfur ion batteries, we need to use the local resources. So we need to work with the desalination plants or the sulfur exporters locally in the country, take the ions they have or the material they have, and we test them out in our lab. We make batteries out of the local resources we have. That's how we will be sure we are ready for the future. That's how we will be sure that we are independent and we can locally produce, manufacture, and synthesize battery material and electric vehicles.
Thank you very much, Dr. Manar. Dr. Taban, so your research includes electric transportation and storage systems. How do you anticipate advancement in these areas influencing future of EVs, electric vehicle technology, and accelerating the global transition to clean energy? What do you think about that?
Good question. Thank you, Dr. Luqman. So, what about the integration and the transition of the transportation from conventional vehicles to electric vehicles, and side by side, moving from the the energy and the electricity generation sector from the conventional to the renewable or the clean energy. So if you imagine the layers that are involved in accommodating or are concerned with accommodating this EVs. So we have the layer of transportation, and we have the layer of the electric grids, and we have finally the communication and the data management layer. So when you place a charger on the transportation network, it will reflect on the electric grid, where it's going to reflect exactly. So which one is more important to us? Is it on the transportation or the electric? Of course, transportation. I will not put a charger on the side road where it's not utilized. I want to put a charger on a main road where it's utilized. So this charger will reflect on a power system on a very critical point. So this point, to supply it, the usual or the conventional is that we do upgrades. So we construct new lines or upgrade the current feeders to accommodate the extra load. There is what we call it non-wire alternatives. Non-wire alternatives are alternatives to installing new wires, and are usually done by installing small generation units at the location of consumption. So what is recommended is that when you build these charging stations, always have the solar panels covering these charging stations, at least to reduce a little bit of the required upgrades, and this is part of what we call it non-wire alternatives. Solar panels are enough. Solar panels are not enough at all. The solar panels can give you very, very little power compared to what is needed. But at least it will it will help. Step by step, you have the solar panels, and then you might have, of course, wind turbines are not economically viable option in the country, but in other countries, wind turbines, vertical wind turbines, small sizes, are viable option. You can have hydrogen produced and then stored and then converted back to electricity. There are many lean options that you can use, but the main challenge is that they have to be used at the location of consumption. So on the highways and at these locations, because if you don't do this, the upgrades in the wires of the power system infrastructure are going to be very costly. So, for example, if you want to install a gasoline station, basically you build the tanks and you build the pumps, but you don't build pipes to supply your tanks. You have these trucks that come and fill your tanks. But on power system, you must have wires. So if the chargers are going to cost you X, and I'm telling you to expand the wires to this location, I'm going to charge you 5X, you will not install the chargers. So the non-wire alternatives should be an option, and the private sector should start more thinking about investing in these non-wire alternatives. Clean resources, local, what we call in distributed generations, on the consumer side, and in this case, on the chargers side. That would benefit both the environment as a clean resources that actually reduce the emissions, and also would benefit the utility by not going to these wires and extra upgrades, and also will benefit the investors installing the chargers, that the utility will charge them less when regarding the installation cost at the beginning of the project.
Thank you very much, Dr. Shaban. I think I have asked a lot of questions, so now I will open the floor for the audience. So we are opening the floor for audience questions. So if you have any question, please ask. You cannot from our panel. Regarding the future of electric vehicles, the advancement, charging of the batteries, we have.
Thank you very much. Very insightful discussion indeed, and I learned a lot. My question to Professor Hussain, you mentioned about the adaptive charging, so where you have fast charging or low charging as the consumer requirement. So, and you mentioned there's a trade-off between, if we go with fast charging, we will may have less lifetime battery. Have there been done any analysis on, the life cycle analysis of how fast charging affects electric vehicles versus low charging as per consumer behavior and the available charging stations that we have? Thank you very much for your question. Currently we have some models, that is the state of health model, as well as the state of charge model for different batteries. Usually we are using lithium-ion batteries in our labs. And we are doing this charging, discharging characterization in our lab, and trying to feed this information to our model and see if you charge the battery with the high power, so it actually causes a heat in the system, and also it causes the degradation because of heat, the chemical reaction, and the internal resistance are changing. So once the internal resistance of the battery is changed, it means that the terminal voltage is going to reduce. And therefore, because of that, the battery that you are using for the EV after some time cannot be used for EV purposes. So therefore, it should be a compromise between charging current as well as the So there are ways that you can know when it's going to be replaced. Because when you do the test, for example, the current cost. And you can see the internal resistance of the thing. So if you charge and discharge in our lab, we saw that if you do the high current charge, so the resistance keep increasing more gradually than normal charge. So it's better to charge your battery slowly. So home charging is better than fast charging.
Thank you very much. Yeah, but this is indeed, but may not be very practical. All people want to go with fast charging. But yeah, just one more question to Dr. Manar, and it caught my attention about collaboration, the point that you raised about industry and academia collaboration. How do you find it? How do you find UAE's progressing in that arena, localizing the manufacturing of electric vehicle batteries?
I think we still need to work on that. We have, yes, we have companies, but again, as I mentioned, we need to have more trust in the local institutes. We need to have more collaboration with the local, the researchers in the local institutes. And again, we need to design batteries that are suitable for our environment. And that's where I mentioned we need to have this loop between the academia and between industry. We really, again, need to gain the trust of the local markets, local investors, local industry, so that we can have more research. Now, I'm talking about sodium-ion batteries. There is gap. There is gap from 1990 to 2010. So it's like 20 years gap compared to lithium-ion batteries. So if we want to accelerate the research, the innovation, then we need to start now. We need to have this trust, collaboration, investment in the young generation, in the researcher, and the future founders maybe of battery materials, electric vehicles from now. That's the solution.
I totally agree. Yeah.
Thank
I'll
you very
open the
much for your.
door for
Any other question from the audience?
Hello, my name is Mohammed. I want to ask, what is the true environmental impact of electricity vehicles, considering factors such as battery production and electricity generation?
Can you please repeat the question?
What is the true environmental impact of electric vehicles, considering factors like battery production and electricity generation?
Environmental impact of battery production. So,
this depends on the material or the type of material we are using. Again, we are trying to shift from lithium-ion batteries. There is concern about lithium, cobalt, nickel that are used in cathode materials now as cathode materials in lithium-ion batteries. And they won't last forever. That's why we want to shift to alternatives. And one of them is the type of material I discussed, which is sodium-ion batteries. It's abundant, available, cheap, environmentally friendly. And also, with the sodium, we can have different combination. We don't need to, for example, use the toxic cobalt or nickel. We can use iron. We can use other different elements. And I think that's the beauty of sodium. We still have a huge window to do research, to innovate. We learned a lot from lithium-ion batteries because they have the same structure. They have the same chemistry in a way. So thanks to lithium-ion batteries, but it's the time to shift to more environmentally friendly. So they are environmentally friendly, of course, but again, that depends on the type of material we are using.
Okay, thank you so much.
And to answer your question about electricity, so each grid, UAE grid, Saudi Arabia, it has a carbon footprint per kilowatt hour. So amount of carbon dioxide, kilogram carbon dioxide per kilowatt hour. So when you connect your electric vehicle to the supply, this is what would be the carbon footprint of the electricity you are using, if you are using the grid. You are using an off-grid system, for example, powered by photovoltaic and storage system, so your footprint as electricity will be zero, because you are using totally clean energy.
Is there any other question from the audience?
You told about renewable energy integration for the power grid to reduce the load when electric vehicles are coming. So what is the scope that if the vehicle is converted to solar powered electric vehicle, what should be the difference? Like extracting more power from PV through grid and charging the vehicle, and also using solar powered electric vehicle, like using solar panels on car or vehicles and using that to charge battery.
Thank you. It's a good question. So let's actually think about a solar panel, one of the most efficient solar panel nowadays. I'm talking about commercial ones that you can buy from the market. So I'm talking about 2 meter square panel, and the power it's providing about 550 watts. So if you leave this panel, which is 2 meters square, which is probably will cover the top of your car, use it for 10 hours, it will give you about 5 kilowatt hour. The battery, for example, for the Tesla or the full range cars that covers 400 kilometers would be about 85 to 100 kilowatt hour. So for 10 hours, you only provided 5 kilowatt hours. So solar power cars would help in providing 5%, 10% maybe of the electric range of the car for charging the battery. But it will not fully charge your battery unless you leave it for days in the sun. But the the parkings and the buildings, covering all of these by solar panels and then connecting the output to the chargers, might give you the impact you are looking for. But you need a large area even to cover a single fast charger or even a 22 kilowatt AC charger.
I would like to add to that point. Actually, a solar powered vehicle could be just a range extended. It cannot actually provide sufficient energy for long distance. It can extend the range. For example, if the battery can support 400 miles, then it can extend to like 400. That's all.
Any other question from the audience? So if you don't have any questions, then I would like to thank the audience for joining the session. And I would like from the ECMR UAE University, I would like to thank all the panelists for joining here, Dr. Manar, Dr. Hussain, and Dr. Daban for joining us, and how your research is doing a lot to our community. So thank you for joining us and for the insightful discussion. Thank you very much. From the whole team of ECMR, thank you very much.